Loop. Alright. I'm gonna go over, this is an iPad mini 2, okay? With, the guy said he tried everything, new digitizer, cleaned out the port and all that good stuff, and still just does not turn on. Okay, so I received this thing, and first thing I did was used my known good LCD and digitizer, plugged it in, and plugged it into my ammeter. And in this case, I have a Droid USB tester. Let's see if I can bring it up here for you guys. Alright, so let me switch cameras here. I'm using OBS now. I'm going to test this out. Alright, so I have a Sony. This is a CX4005, alright. And let's see how it works. Alright, so I have a Droid ammeter here. You can get it on Amazon for like 10 bucks. And so I plugged it into my Droid and was getting a solid 0.2 amps. Okay, which is not even, it may be in recovery mode. It may be something's wrong with it basically. It wasn't drawing any power or anything like that. So those are basically all of all the information that I had based on my initial testing. Okay, so next thing I did was I just looked under my microscope, and here's the first thing I always do is look near, where the tech could have damaged something. So basically there's a black tape over here, and I just removed it and took a look, and so the way you can tell if it's iPad mini or mini 2, mini 3, or whatever is this row of resistors right here. If this row is here, it's a mini 2. You can also look in the back for the model number. So that's the easy way. So anyway, so I just kind of took a gander at all the pins, which is a pretty common problem, and more importantly, since there's no power really, I mean it could be LCD related, maybe a short here or something like that, or maybe battery related. Okay, so I didn't see anything. I mean this thing's clean. Nothing looked out of the ordinary. No missing components here at all or anything like that. Next thing I did was I popped this the heat shield, the EMI shield off, and kind of took a look around. Really, you really just want to use your eyes just to see if there's usually if there's a burnt component, you'll see it cracked or you'll see it black. You'll see something, okay, and you don't really have to go. I mean, you don't have to go into too much detail, but just kind of take a look around. It's just use your eyes. That is always number one. Okay, I mean, what stood out to me was probably this right here. This is probably nothing. I mean, this is a coil right here, and it doesn't really serve a whole lot of purpose aside from limiting the current flow through to it. And I mean, it's not cracked or anything. I mean, this looks probably heated, so that may have been part of the problem. I mean, I don't think this component is the problem, but something else is the problem, and this kind of overheated, This right here looked a little bit weird to me, but I don't think it's anything either. I think this is probably just the black stuff that they sprayed on top of here. Okay. So I didn't see anything. I mean, so the next thing I did was I just took my multimeter to it and put it in the continuity mode. And the first thing I do is, you got two big coils here. Okay, I know that from experience. I know that you can always go to the schematics or ZXW tools and check to see what they're connected to, but usually they're connected to the backlight. Okay, and I know that VCC main powers the backlight usually. So what I did was I just used my multimeter in continuity mode, touch one side to ground, and basically just kind of check both sides. And I know that the coil should not beep on both sides. So VCC main usually powers one side and other side 1 second. Let me double check. Alright, so I got ZXW tools here. And these are my coils here, so you can't really see which side is VCC main, but my guess is probably this side is VCC main. Alright, since there's so many connections to it. Okay, so this side is VCC main. And the other side is not. So I know that neither side should be shorted to ground. Alright, so VCC main should not be shorted to ground. Okay, if it's shorted to ground, then you have a shorted ground on VCC main. So that's a whole nother problem. So anyway, so once I tested a few other components, and that's what I found. So now I know that I have a short to ground on VCC main. Alright, now for an iPad mini 2, normally you just call it a day, okay? Especially if you don't see anything weird, because you can sit here, chase this VCC main short for hours and hours and not get anywhere. And it being an iPad mini 2, you can get a replacement device for whatever 150. So it's really not even worth it. Okay, so I just kind of just took a look a little bit more in depth to see if I saw anything that kind of stood out to me. Maybe it's an easy fix. I can fix it for so what I did find was this. All right. So I just noticed this little bead of solder here, and which doesn't mean a whole lot usually, but it's weird. All right. It's weird in the fact that there's a bead of solder here. Shouldn't be. Which means that this probably overheated. Okay. And so I went back to ZXW, checked, and sure enough, this is VCC main right here. And I still don't know if this is the problem or not, because I haven't desoldered it and put a new one on, but my guess is that this right here was probably the problem that's shorted. Alright, so from here, what I'm going to do is just desolder that, and I'm going to use my hot tweezers. My silly JBC nano tweezers. I'm going to get the black stuff off first. And I'm going to put a little bit of flux on it just to help me remove it a little easier. You can also put a little, let's put a little low melt on it, because I really don't want to use heat here because the battery is so close to it, and I really don't want to burn the battery. So I'm going to get a little bit of low melt solder paste. This is the 138 degrees Celsius. That's what it melts at. I need to get a new tube because mine is crusty, and I don't put the cap on it or anything like that. And mine is cooked, so it's time to get one. Time to get a new one. I didn't really like this SRA stuff anyways. I'm going to call it a day with SRA from here on out. Okay, there it goes. So it makes things a little bit easier. Okay, so to confirm that this was my problem, you have to disconnect your cap from the circuit and check it with a multimeter. Continuity mode again, and if this beeps, then we know that this was the short. Beep. So the capacitor is not supposed to be shorted. Okay, it's supposed to be an open circuit with if there's a charge on it, then there will be a slight voltage across it. Okay. If it beeps, it is shorted and it is bad. So we already know that this beeps. All right. So the next, we can also confirm by putting our leads across the pads to make sure that our short to ground on VCC main is gone. And okay, so it's okay if one side beeps, both sides doesn't beep. Okay, so our short to ground on VCC main is gone with the removal of this cap. So what I'm going to do now is clean it up, put a new cap on, and I think this problem will be fixed. If all goes well, I know a lot of people still struggle with diagnosis, and it's not easy, but what am I doing here? Okay, let's find out what component it is, and then C5880. C5880 is a 10 microfarad 6.3 volt 0402. So I will just grab one because I know I have one of those. So let's see, 10 microfarad 6.3 volts. Do I have one? Pretty sure that's the common. Hold on a second. Is that a backlight? Yes, it probably is. The VCC main. 10 microfarad. Okay, so that's a VCC main backlight. Or I'm sorry, on the iPhone 6. Yeah, that blows often. So another commonality is that there's certain caps that seem to kind of crap out occasionally. So when you're diagnosing, you can also kind of look for dang it, where did it go? I just cut it and it's gone. Why does this happen to me all the freaking time? Alright, let's cut another one. Alright, so let's put it back on. Now I took it out and it's gone. What the hell? Alright, it's 3 times the charm. Oh my gosh. It's gone again. It's pissing me off now. Okay, 4 times the charm. This is the 4th cap because I suck at cutting these damn things. Alright, there you go. Alright, so here is, okay, so here we go. Um, so tin it a little bit. Oh no. Oh, okay. So that's how not to solder. Alright, so we're good here. Let's double check to make sure there are no shorts again. And it is not shorted. Actually, looks like it's low resistance to ground. Now, hold on a second. Nope. I'm getting 308 ohms. So there may be another problem. Not really sure yet. That's low resist. That's considered low resistance to ground. So I'm thinking maybe I might replace these other two caps as well. I think I will actually. There's one. Two. So before I do anything with these, I'm gonna test them just to make sure that they are fine. So that one's fine. Yeah, this one looks fine too. So let's test this again. It could be nothing really. Well, maybe it was nothing. I don't know. Anyways, I'm gonna replace them anyways, and I know that looks like a mess, but I swear it will be cleaned up. Might be time for a new Q-tip. You know, it looks like there's something stuck to that, so I need to get that off. That's the part of the capacitor that's still attached to there. Okay. And this is bridged here, so alright, that's good. Alright, so let's put some new caps on there, and then I think I'm hoping that will be, we'll call that a day. So also I don't lose any more caps in the process of cutting them out of the tape. Alright, so there we go, 2 caps. I got my, let me get some flux on there. And we will just plop them on there, and I think we should be good to go. Right, I don't think that is really melting very well right here, so let's see if we can tin that. A nice little tin going there. Alright, there you go. Okay, so that's good. Let's get our second cap here. Clean my tip a little bit. Alright, so I think we're good there. Let's just clean this up here. So I'll even use the Q-tip. And I'm pretty confident that this is probably going to work here. Alright, we can do one more test just to make sure it's not shorted, and check the resistance as well. So I'm getting OL now, which is good. Oh. No, that's still low resistance. Maybe it's supposed to be low resistance. I don't even know. What the? Maybe there is something wrong. I don't know. So the end ones are OL, and then the middle one is low resistance for some reason, still. So I'm going to do this. I just need to make sure that it's not shorted ground or anything. I don't even know if that's part of ECC main or not. Okay, so that's low resistance to ground already. And that is not. And that is not either, so. Okay, let's find out what this is before we start. So these are all VCC main, so shouldn't be low resistance to ground. Actually, let's take a look at this one. Well, let's just put it on powered up, see what happens. Because at this point, I have no idea why it's giving me that reading. Maybe it just needs to be charged or something. I don't know. We're done. Let's see what happens. Let's plug it in. Good. So dirty. Alright, get my screen out here. Alright. My guess is that it's probably not charged. Anyways, I'm going to stick my ammeter in here just so that I know what I'm dealing with. And so I got 0.46 with an Apple logo. And my LCD is busted, so I'm getting 1 now, 1.10. Jumping around a little bit. I know you guys can't really see that, but it did power up. So, not sure if you guys can see that or not, but there you go. It is powered up now, so I think it's at 100% battery too, so we're good with the charge. So I think we're good with this. Yep. So, anyways, we're good. I'm gonna go ahead and close this up and go with it. I don't know why there's low resistance. I'd probably have to check. Another logic board just to make sure that it's not supposed to be, or if it's supposed to be low resistance. That's my guess because everything is powered up and working. So there you go. So that's kind of how you diagnose and troubleshoot no power iPad Mini 2 or anything for that matter.